So, welcome everybody. In 2019, I gave a talk about Ceph's performance on NVMe. When NVMe was fairly new, everybody started to deploy NVMe. We were all excited. What kind of performance could we get? And on the schedule, you will find that it says revisiting Ceph's performance after 4 years. But I think that COVID just, I was missed by a year because I thought it was in 2020, but it was in 2019 when Ceph.con was in Barcelona. So that was my mistake. But the presentation here says 5 years. So welcome all. Still have a group of people coming in. So take a seat. We have more than enough time. More than enough time. So who was in Barcelona in 2019? One hand? See a couple of hands? Okay, that's good. Who watched this talk in 2019? Okay. One half. Okay. Fair enough. So if you take a seat, then we got more people coming in, more coming in. As I said, we have enough time. Okay, so quick agenda, you can watch through it. Let's start with the who's who. Who am I? So Wido and Hollander, born in the Netherlands. I got 2 kids, wife, all the intros. But interesting is I've been working with Ceph since 2008. There was no version where Ceph was released. There was still Sage developing Ceph, and just a handful of people looking at Ceph. I've been working for a long time. I used to be active in the Ceph community as a trainer and consultant. Over the past few years, I moved to a different role within the organization where I'm now CTO. I don't actively run Ceph anymore, so I don't go on a CLI and run Ceph, but our companies within our group run Ceph extensively. And I help our companies actually deploying Ceph successfully, guide them through the process, and some are still actually seeking towards deploying Ceph, and they still think it's scary. And I'm like, scary? What are you talking about? Ceph is not scary to run. So I'm a techie enthusiast, as I said, CTO nowadays. I'm a IPv6 fanatic, something you will hear during the presentation. I will encourage you to use this for Ceph. So the company I work for, Your.Online, has a global presence with hosting companies. So you will find all these individual brands over the world within our group, and they have something in common, is that they use Ceph in their infrastructure, or they have been using Ceph for a long time, or they're about to deploy Ceph in their infrastructure. It's not me telling them, it's that they actually want to deploy Ceph. So that's a bit of my background on who I am and what the group Your.Online is. So what is performance? That's, I think, an interesting question. Because, and I will not go to this slide yet, this morning during the keynote, there was a talk about that we reached a terabyte per second with Ceph performance. Awesome, right? I think that, as was also said, that Mark said, this is people now talking about Ceph who were previously not talking about Ceph. But what is performance? Can somebody name what performance for you would be? When is a Ceph cluster performant? Is it bandwidth? Is it latency? Is it a super high amount of IOPS? So what is it? And in 2019, I gave this presentation together with Piotr, who worked at OVH at the time, and we tested with the various versions of Ceph, and we got to a latency of 0.7 milliseconds, which translates to about 1,300 IOPS, which we got from a single Ceph environment. Now, everybody always says, because the talk this morning said 25 million IOPS, and I think this is a crucial element when you look at storage, is it's very difficult to compare performance. If you look at any white paper of somebody showing the performance of their storage environment, they're all talking about hundreds of thousands, millions of IOPS. But then you always have to ask, what's the I/O depth and what's the block size? And were you reading or were you writing? And I can tell you, they're always cheating and taking the easiest route. They're reading large blocks with a high concurrency, and then they can say, we had 1 million IOPS. And as you can see, my conclusion back in 2019 was, well, we can get a latency below 1 millisecond with a single thread, 4K write, and 3X replication. which was on 10 gig at the time. And I already said then, don't expect the full NVMe performance. Well, we heard about Crimson this morning during the keynote. Maybe some of you were here at the Auditorium B at the Crimson talk where they gave an update. Well, back in 2019, we were talking about Crimson. It will take, I think, in my opinion, it's great work what they're doing, but a couple of years before Crimson is ready to deploy and actually get the full performance. And it's not going to be an easy task to rewrite the OSD and take the full potential of an NVMe device. For some workloads, just running bare metal directly on the NVMe is still better. You don't get the high availability, you don't get the scalability, but you do get performance. And there's this triangle. Pick 2 from the 3. You can't have all 3. So you can have performance, but yeah, well, you don't have availability. You can name it. So, and again, for Ceph, consistency is the #1 priority. I have never seen in this about 20 years that a Ceph cluster lost data because of Ceph itself. It was always human error or hardware failure, which simply caused data to go lost. But Ceph itself, I've never experienced Ceph losing data. So I think that performance is writing a 4K block in the queue depth of 1, and that's performance. I think that is the basic element of performance which you need to look at. What is the latency it takes to write a file, to write a block to a Ceph environment? Because reading is cheap. You can cache reads and all kinds of layers. If you're running an RBD application, which is a virtual machine, you will have the page cache within the virtual machine doing caching for you. So reading is not that difficult. And if I look at most environments, and I'm biased because we're in the hosting industry, I will see that most Ceph environments are writing more than they're reading. And only when the backup cycle is running in the night in virtual machines, you might see a spike in reads, but overall, it's about writes. And therefore, I get back to the point, I think that a 4K write in a single thread is the most important one. A database, which needs to write a transaction, wants to have a low latency. The lower the latency, the quicker the transaction succeeds. More transactions, yeah, if you scale out to multiple databases, you get more queries at the same time, but the latency of the individual query will not go down. That's where we need latency. Same goes if you have PHP scripts running or other things, just writing files on a file system. Anybody here from the hosting industry? The nightmare of the billions of files on a single server. Well, all the small IOs writing those files and trying to do rsync to a different system. That's all about small I/O, small I/O. So I'm always looking at latency. So don't expect me to present millions of IOPS. I look at something different. So what is performance? Well, do you want one or do you need one? I think that's the question you need to ask yourself. Do you need to go 400 kilometers an hour, or is maybe 200 sufficient? And my main message is that you think about your application. So you can do benchmarks, and you can FIO for your benchmarks or whatever tool you want. But in the end, you need to make sure that your end user application gets the performance which you need for the end user. So we can endlessly be benchmarking, saying, it needs to go better, but sometimes maybe it's just sufficient for the workload you're looking at. Or you can mask the not so great performance, not the right wording, but no, the performance by caching somewhere or reducing the amount of I/O. Because I think that I/O is the most expensive thing. We just think it is fine. And I encounter so many developers who say, works on my laptop, because we give them a MacBook with an NVMe and they just develop on their MacBook and they say, it's super fast. And then they start complaining that in the data center it's nowadays slow. So maybe we should give developers spinning disks again in their laptops. That's yeah. So less memory, spinning disks, make it work on your laptop, and then go to the data center. So the other way around. Anyway, my point is, make sure performance is not cheap. Latency is not cheap. It's not easy to reduce latency. And at some point, you will be running into simply laws of physics. And I won't be talking about laws of physics, by the way, here at CERN, because they know better than me. But speed of light is going to become an issue at some point. Latency will be there. It's something we cannot neglect. So, anyway, My benchmarking setup. A shout out to Involve, it's one of our suppliers. They borrowed me some hardware during the summer. Epic Generation 4, 3 Dell boxes with some NVMEs in there. I could have asked for more NVMEs, but I was looking at latency. So even a single NVMe would have been sufficient in these boxes. I just wanted to get a newer generation AMD, see how it would be performing. 25 gig, you get the point. I did the benchmarking this summer. This is when I had the time and had the hardware available. So big thanks, shout out to Involve for providing the hardware for me for a couple of weeks. And software, so yeah, I needed to use Reef because Quincy wasn't out yet, so version 18, but I don't think there's going to be a major difference. FIO is my benchmarking tool. Runtime 60 seconds is sufficient. I ran it a couple of times, making sure the cluster was warmed up. IO that for 1, you get the point. And all done on Ubuntu 22.04. So again, QDEV1, block size 4K. And then we start talking about tuning. And I have a few interesting things where people start tuning because they think they need to tune. So, they install Ceph, they got it running, and then they're, okay, let's go, tune. And then they start looking at all the configuration options and think they need to change them. And I have one story. This is not to blame anybody, but I flew to Sweden at some point from Amsterdam. I got a call. I needed to fly to Sweden. I flew to Sweden because I couldn't access the cluster remotely. They said, we have a terrible problem. You need to come over. So I flew over to Sweden that day, and I got there, and I fixed the issue in about 45 minutes because I looked at the Ceph.conf, and somebody just copy-pasted something from the mailing list, put the whole Ceph.conf in its cluster, and it worked for 2 years until it didn't work anymore. So if you start changing, if you think I'm going to be tuning, be aware it's very expensive to do tuning. So let's say you run Reef now and you want to go to whatever version in the future. You change a value from 300 to 200 because that gives you a better performance. But over time, testing is being done, but you have set the setting from 300 to 200. Doesn't matter which setting, but you change something. And then the developers figure out, 100 is better than 300. So we're going to change the default from 300 to 100. But you still have 200 set in your configurations file. So you're now suddenly getting worse performance than a default setup will be because you thought you were smarter than the developers and started using a different one. So my recommendation is if you think that certain settings need to be changed, give the feedback back to the community, open an issue, start a discussion on the mailing list, because maybe we need to change the default. The way I always designed Ceph environments was trying to change as least as possible, and whenever you do a major upgrade, probably revert back to the default Ceph configuration and try again. Otherwise, you'll have these Ceph configurations just growing and growing and growing. After a few years, you're looking at your colleague like, any ID? No, it was in there for a few years, so don't touch, don't touch. It's the things you see happening out there, and it's not only with Ceph. It's interesting that Varnish, the cache, they say give end users the least amount of configuration options as possible. So less configuration is better for most end users, otherwise it becomes a tuning party, which you never know how it ends up. So the only thing I did for the tuning in this case is tuning the CPU. Pinning the C state to 1. So if you're not familiar with C states, it's a power saving state. It runs from 7 to 0. And 7 is a super deep sleep of the CPU. And waking up from that sleep to C state 1 takes time. And this is where it gets interesting because that's latency for the CPU waking up, being able to process the request, and then answering that the write has been accomplished. Because 3x replication, 3 OSDs need to wake up, acknowledge, and then send the acknowledgement back to the client. And then also set the governor of the CPU to performance, making sure it stays clocked at the highest frequency. Yeah, 6 OSDs in total. 3 nodes, 2 OSDs per node, and running happily there with, what was it? 123 gigabytes of data. Not so, but it was benchmarking, right? Benchmarking for latency. And I said I was going to go to V6, so here we go. So one thing I would like to mention is that the networking was done using some Dell boxes with 25 gigs running Cumulus Linux, no layer 2. A full BGP setup where every host was running FRR and advertising a loopback address, V6 address, and receiving a default gateway from the top of rack. And this is a setup you don't see that much with Ceph, and this is why I also would like to use a bit of time to explain, is why I think that it's a good thing, because layer 2 isn't that scalable. And if you want to think about scaling out a Ceph environment, a routed setup nowadays, modern boxes switches can route very fast. So MTU 9216, no VLANs, a full L3 environment using BGP unnumbered towards every node. So why L3? Because I say we're using the future of storage, but you're using the past of networking. My opinion. So, but if you look at all the talks of all the hyperscalers, you see that they are building their infrastructure on V6 only, and they deploy V4 only where really needed. And I've been talking with a few people here in the conference who also run Ceph on V6 with BGP as their backbone, but yeah, it's not really that fancy to talk about. And this is interesting. Telemetry.ceph.com doesn't have a V6 address anymore. It used to have. And we saw a dip in the telemetry data this morning. And my assumption is that a few multi-petabyte environments can no longer report to telemetry because the V6 connectivity is gone from telemetry. So we're chasing that as well. Okay, so I think a modern network should be built on V6. Fairly simple setup. So the hosts were connected. They were talking eBGP to the top of rack routers, which was talking BGP again to the upstream. But in the end, the traffic stayed within those two top of racks. They were just talking BGP to each other. Anybody running Ceph with BGP here? Nice. Phew. Okay, great. Well, fairly simple. BGP unnumbered. The two interfaces, you see that they both have a BGP session established, and that they are sending one prefix and receiving one prefix, sending their own address and receiving a default gateway from their upstream. So if you would then look from the upstream, they would get a default gateway which could go to both interfaces. So this is how the machines could reach each other. I got the configuration in here for anybody looking at the slides afterwards. They'll be on the schedule.com, so you can copy-paste from the slides if you want the FRR configuration. But in the end, I see there's a typo here, so that's my mistake. The typo is over there because the address, this should be the other way around. I made a typo there. Anyway, forgive me. But it announces just its loopback address and towards the upstream. So then I started with networking performance. So some TCP with using QPerf, do some TCP benchmarking. So 13 microseconds and then some ping. The ping was with 8K. I just wanted to make sure that jumbo frames were working properly and that the latency was acceptable. You can probably shave off a bit of the network latency, but my conclusion is going to be is that although you might spend a lot of time on trying to reduce network latency even more, I can tell you the Ceph code is more of a bottleneck than the network is. So that is the conclusion I'm giving away right now. And just for sake of clarity, I do an iPerf test, making sure the bandwidth works. So the results, because this is what you came for, right? I could have just skipped to the last two slides and just showed the results. But let's summarize very quickly again. So 2019, Ceph version 14.2, 18.2 nowadays, so Ubuntu 18.04, 22.04, you see it, a newer generation of Epic and a newer generation of the NVMEs. And if we look at the results, we see that the latency went down, but not. Well, it's pretty interesting if you look at the numbers. So in 2019, we had a latency of 772 microseconds. In test 1, where the CPU was not pinned in a certain C state, nor did I set the CPU frequency, I was already reaching a performance of 672 microseconds. So better than all the tuning you could do in 2019. I didn't have the time to actually figure out, is it the Epic or is it the Ceph code? Because that's very difficult, and you need to start installing all the different versions. My assumption is that about 70% is probably the AMD Epic, which is just much faster, and about 30% is the Ceph OSD code itself. My conclusion after talking to a couple of people who said, yeah, well, we didn't have that many changes over the last 5 years, really focusing on the latency. But you see, all the way down to test number 3, it's about a 40% decrease in latency if you're running the latest AMD Epic with all this tuning set. So, and then you also see that disabling logging inside Ceph saves you a few, about 15 microseconds of additional latency you shave away by disabling logging for the OSD. If you compare that to IOPS, we have a pretty big jump, almost double the amount of IOPS we get from a Ceph environment from 5 years ago to the modern environment using a newer generation AMD EPYC. And I use these EPYCs, these boxes. I don't have a picture of these boxes, but these are the 1U boxes with a single AMD EPYC, 16 cores, and then 10 NVMe's or 12 NVMe's, which the setups you have nowadays. I think that's still a really good box to use for a Ceph environment. Simple, no NUMA issues, one network card connect to one CPU, all the NVMe's to one CPU, very predictable performance. On the TCO, it could be that a bigger box with multi-CPU is cheaper if you look at it from a spreadsheet, but I think from operational-wise, having these smaller boxes in 1U with 10 NVMe's is a pretty good sweet spot. Nowadays, I think these boxes are around 12,000 euros fully loaded with 4 terabyte NVMe's, depends on where you buy them. So I think this is the main thing, and I said we have a sufficient amount of time, so my main thing I wanted to mention is that I think if you look at performance, look at latency first. I know those are the dull numbers, those are the low numbers, look at latency, and then start figuring out what you want to do. But latency, that's the baseline underneath all the performance. Just all high QDEPs is only masking latency, and you are fooling yourself if you think that you have a high performance if you have a high amount of IOPS. But yeah, what is performance? It's a question you have to answer for yourself because it depends on your application. So that was my main talk. Any comments, questions, flames, remarks?
If I remember correctly, you were using AMD EPYC first generation, which did not have PCI Express as a bus, but was PCI Express on a chiplet. Have you tried pinning, I know it's 5 years ago, have you tried pinning the OSD threads to a certain CCD?
No. I did it with Piotr together. He also did our benchmarks. We came to the same results. I don't know exactly what he did in his benchmarks, but we didn't try the certain pinning. No. There's one in the back.
I have a question about AMD processors, because in this 7.3, 7.2 there was some, I think, bug, and in that time we had to use IOMMU pass-through in the kernel configuration. It's changed a lot in
Yeah, we have set that setting in 2019. Yeah, I didn't do it this time, but yeah, the IOMMU PT, that setting was set on those environments. Yeah.
in this new test you don't set it.
No, it wasn't set in this new test. No.
How do you think underlying disk performance impact?
Yeah, so the underlying disk performance, the latency, of course, of the underlying NVMe is important, but you will see that most of the time is being sent by the CPU, because if you look at the difference that pinning the C state and the performance and the governor does, that's a huge impact. You would need to try benchmarking with a memory drive, for example, to also eliminate the NVMe. I think that any data center grade NVMe is sufficient. You will not utilize the full performance of an NVMe with a single OSD with the current state of the code. Well, everything was clear, and then I gave you back 12 minutes of your time.